Hello and welcome to SigmaXL video tutorials. In this video, we'll be demonstrating the new advanced design of experiments in SigmaXL, specifically Augment 2-level Factorial Screening Design. We will use the Augment tool to demonstrate how to add axial points. This example uses a 2-level factorial screening design with the factorial plus center point portion of a response surface layer cake baking experiment given in the SigmaXL workbook. The response variable is taste score on a scale of 1 to 7, where 1 is awful and 7 is delicious. Average score for a panel of tasters has been recorded. The continuous factors are A, bake time, 20 to 40 minutes, and B, oven temperature, 350 to 400 degrees Fahrenheit. The experiment goal is to find the settings that maximize taste score. After the analysis, the design will be augmented to add axial points, making it a response surface design. To begin, click SigmaXL, Design of Experiments, and under the Advanced Design of Experiments section, select 2-level factorial screening, 2-level factorial screening designs. The default design has 2 continuous factors. It's a 4-run full factorial with 1 replicate, 1 block, and 0 center points per block. Looking at the design power information for the default settings, we can see that this initial 2-factor 4-run design has a very low power to detect a large effect size of 3 standard deviations, and only medium power to detect an extreme effect size of 6 standard deviations. Scroll down to view the full report. With terms in model as 1 main effect, error degrees of freedom equals 2. Typically, we want terms in model as all main effects, but here, that only gives error degrees of freedom equals 1. If terms in model is selected as main effects, or ME, plus 2-way interactions, then error degrees of freedom equals 0 and power cannot be calculated. Select number of replicates equals 2, number of blocks equals 2, number of center points per block equals 2, and design power information, terms in model, as all main effects. This design now has a medium power to detect an effect size equals to 2.5 standard deviations, with error degrees of freedom equals 7. So, is a dramatic improvement over the single replicate case. This is the design we'll use for the cake bake example, as it matches the factorial portion plus center points of the response surface design. Enter the factor names and level settings for these continuous factors as shown. Enter the response name as taste score. Uncheck randomize center points. Select seed base value with the default 1, 2. We'll go over these options in a moment. Click OK. The Design of Experiments worksheet is produced, including the legend, block generators, aliasing of effects, and design power information. Note that by unchecking randomized center points, the center points are approximately equally spaced within a block. With 2 center points, they are the first and last runs within the block. If there are 3, then first, middle, and last runs are used. Since randomized runs is checked, the non-center points are randomized within the block. Note that the block number is also randomized. Using a fixed seed value of 1, 2 means that the random run order will always be the same. This is useful for instructional purposes or following the example in the SigmaXL workbook. Open the file Advanced 2-level Factorial Example cakebake.xlsx. This has the design worksheet populated with taste score values. Click SigmaXL, Design of Experiments, and under the Advanced Design of Experiments section, select 2-level Factorial Screening, Analyze 2-level Factorial Screening Design. Select taste score and click Responses Y. In the term generator, select main effects plus 2-way interactions. Click Select All. We will uncheck Include Center Points because we want to be able to clearly see the influence of center points in the residual plots. We will redo the analysis later with Include Center Points checked. we will use the default advanced options, so no changes will be made. Clicking OK will provide us with the analysis. Note the significant error, lack of fit, with p-value equal to 0.017. Only bake time is significant, with a p-value of less than 0.05. And the R-square adjusted, and R-square predicted are low. Click on the Residuals Taste Score sheet. The residual plots show obvious non-random, non-normal patterns, and in particular, the residuals versus bake time and residuals versus oven temp show strong curvature. Now, we'll reanalyze the experiment and include center points in the model. Click Recall Last Dialog or press F3. Check Include Center Points. Click OK. All model terms except blocks are significant. The R-square values are high and there is no significant lack of fit, with a p-value of 0.91. The residual plots also show no obvious patterns. Note, however, that the center points term is significant, so this indicates significant curvature or quadratic effects. This means that we cannot use the model as is to make predictions. We need to specify quadratic terms for bake time and oven temp. The current full factorial plus center point design does not permit these quadratic terms to be added, as they would be confounded. We need to augment the design to add axial points, effectively converting this design into a response surface design. We could also refit the model with include blocks unchecked, but we will not do this for the purposes of this video. We will now add axial points to this design. Click on Sheet Cake Bake Example. Click Design of Experiments. And under Advanced Design of Experiments, click Augment 2-Level Factorial Screening, Augment Design. The default dialog design is given as Augment Type Fold Over Design. Select Augment Type, Add Center Axial Points. Uncheck Add Center Points, since we already have center points in the original design. Use the default checked Add Axial Points, number of replicates equals 2, which matches the number of replicates in the factorial design. Select Face Centered alpha equals 1 to match the original Cake Bake RSM design. Check Randomize Center Axial, select Seed Base value equals 12, and check Fraction of Design Space, or FDS plots, with default options, Terms in Model, Main Effects plus 2A Interactions plus Quadratic, Confidence Level 95%, and Include Blocks unchecked. Click OK. The new worksheet augments the original factorial design with 8 new axial runs randomized within a block. That is, 4 axial runs replicated twice. The fraction of design space and report are also provided below. The margin of error, interval half-width, at the 95th percentile, that is, 95% of the design space, is 1.084. We then multiply this by the estimate of the model standard deviation of 0.138 given in the factorial portion to obtain a margin of error for taste score equals 0.15. Given that the taste score is on a 1 to 7 scale, this is an acceptable margin of error for prediction. Open the file Advanced 2-Level Factorial Example, Cake Bake with Axial Augment.xlsx, which has the augmented design worksheet populated with taste score values. Click SigmaXL, Design of Experiments, and under Advanced Design of Experiments, select Augment 2-Level Factorial Screening, Analyze Augmented Design. Select Taste Score and click Responses Y. Quadratic terms can now be estimated because we augmented the factorial design with axial points. Click Select All. Check Display Regression Equation with uncoded coefficients. We will not modify advanced options. Leave Include Blocks unchecked. Click OK. Now we have high R-square adjusted, and R-square predicted. All terms are statistically significant, and there is no significant lack of fit. We will not review the residuals or main effects interaction plots here, as that was already done in the earlier analysis, but we will review the use of the predicted response calculator, optimize, and contour surface plots. Scroll to the predicted response calculator. Enter bake time equals 23 and oven temp equals 368, as given in the original Cake Bake RSM design. This is to predict taste score, with a 95% confidence interval for the long-term mean and 95% prediction interval for individual values. The margin of error, interval half-width, is 7.21 minus 7.05 equals 0.16, which is close to what we estimated using the FDS plot. Given that the taste score is on a 1 to 7 scale, this is an acceptable margin of error for prediction. Next, we'll use SigmaXL's built-in optimizer. Scroll to view the optimize options. Here we can constrain the lower and upper bounds of the continuous predictors, but we will leave the default settings as is, which are obtained from the minimum and maximum of the predictor values. Scroll back to view the goal setting and optimize button. Because we're trying to maximize taste score, specify goal equals maximize. Click optimize. The response solution and prompt to paste the values into the input settings of the predicted response calculator is given. Click yes to paste the values. Next, we'll create a contour surface plot. Click the Contour Surface Plots button. A new sheet is created that displays the plots. The table with the hold values gives the values used to hold a predictor constant if it is not in the plot, so is not applicable here with only one plot based on two continuous predictors. This contour plot shows us that an approximate maximum taste score can be obtained with a bake time of 23 minutes and an oven temperature of 368. Use the contour surface plots in conjunction with the predicted response calculator to determine optimal settings. This concludes the SigmaXL tutorial video for Augment 2-level factorial screening designs. Add axial points. For more videos, visit www.sigmaxl.com or join us on YouTube. Thank you for watching.